In this video, we're going to talk about how to solve the bisection method using examples. And in these examples, we are going to learn how to find the roots of functions. We're also going to learn how to tabulate values. We're also going to learn how to stop the bisection method iteration. So let's quickly take a problem and solve. So look at our problem on the screen. Use the bisection method to find the roots of f of x cubed plus in the interval. So before you solve problems in the bisection method, there's quite some things I want you to know. So most times you'll be given an interval. So your interval is often given in this format, 2 points. So we call these 2 points A, comma, B. Okay, so the first point is often referred to as A, and then the second point is often referred to as B. So for your first procedure in solving the bisection method, you need to find the midpoints between these 2 points. So that midpoint, we call it C. Okay, you can call it any other letter, but most times it's called C. So to find our C for our first step, we say C is equal to 1 plus 2 divided by 2. So this is equal to 1 plus 2 is 3 divided by 2. So this is 1.5. Now the next step is to find f of c and check if f of c is equal to 0. Okay, so let's find f of c next. So we know our f of x to be this function. So our f of c would be f 1.5, which is equal to plugging 1.5 into this. So our f of c is equal to 2.375. Now, the second point is to check if f of c is equal to 0. So we say that f of c is not equal to 0. So there's something I want to note here. If f of c is equal to 0, then we've gotten our answer. So our iteration will terminate. We found the answer to our problem, so stop using the bisection method. But if f of c is not equal to 0, then we need to go to the next step. Next step is to find f of a and f of b. Okay, so to find f of a and f of b, we are simply going to be plugging these two values into the original function that we are given. Okay, so for f of a, we have equal to f of 1. So plugging it gives us minus 5. Okay, so for our f of b, we have equal to f of 2. So this is equal to 14. Okay, so we've gotten our f of a and f of b. Okay, so let's clean up space for more analysis. Put our f of a as equal to minus 5. I got our f of b as equal to 14. Okay, so the next step is to replace a or b with c on the interval, depending on the sign of f of a and f of b. So if you look at f of a and f of b, f of a is less than 0, f of b is greater than 0. So the next step, our original interval is a comma b, right? So our point here is to replace a or b with c, depending on the signs. Okay, so we knew that f of c is 2.375, right? Okay, and this was greater than 0. So in order to know the one that we replace with c in this interval, we need to look at the signs. Okay, so the signs of f of a is less than 0. The sign of f of b is greater than 0. Or the sign of f of c is greater than 0. So f of c will be replacing f of b. Okay, so that means c will be replacing b in this case. So our new interval will become f of a. A is still held intact. So this is 1. And then our c is 1.5. So these are new b and these are a. Okay. So instead of doing this again and again, I like putting it in the form of a table. Okay. So that it will ease the stress. But you can continue doing it like this, like this, like this until f of c becomes approximately 0, right? Comes approximately 0. So let's draw our table. So from our analysis so far, this is what we've gotten on our table. Okay, so for our second iteration, we're going to be seeing second iteration, our a still remains our a. So this is 1, and then our b becomes 1.5. So we are now ready to start our second iteration. So for our new c, we know that c is equal to 1 plus 1.5 divided by 2. So 1 plus 1.5 is 2.5 divided by 2. 2.5 divided by 2 is 0.25. Okay, so our new c is 1.25. Okay, so if we do f of c, which is equal to f of 1.25, we get in. So this is equal to minus 1.7969 to 4 decimal places. Okay, so we know that f of c in this case is not equal to 0. So we are now free to go to our next step. So for our next step, we see f of a, we find f of a, which is f of 1. F of 1. So f of 1 is equal to minus 5. Then find f of b. F of b is equal to f of 1.5. So f of 1.5 is 2.375. Okay, so 2.375. Now, we need to replace A and B with C. Okay, so what will determine what we replace A and B with C is the sign of the f of A, f of B, and f of C, like we did before. So we know that f of C in this case was less than 0. F of A is less than 0. F of B is greater than 0. So we'll be placing f of A. We're using f of C to replace f of A because f of A is the one that is less than 0 here. Okay, so let's write out what we've gotten in this table so far. So that for our new interval, we now have. So for our third iteration, we'll have A to be 1.25 and then B to be 1.5. Okay. So we're ready to do our third iteration. Let's clean up space. So you can also pause the video to try to solve this part of it yourself. Try to fill up this table yourself. So for our third iteration, we know that C is equal to A plus B over 2. So our new A and new B is 1.25 and 1.5. So 1.25 plus 1.5 divided by 2, 1.375. Okay, so we know that f of C is equal to f of 1.375. So if you plug 1.375 into this, we get 0.1621. Okay, 4 decimal places. So this is not equal to 0. F of 1.25. So f of 1.25 is minus 1.79 969. And then our f of b, which is equal to f of 1.5, is equal to 2.375. Okay, so from here we have all our values down. So we knew that this is greater than 0, this is less than 0, this is greater than 0. So to know the value of a or b that we'll be replacing with c, we check the signs. So greater than 0, greater than 0. So c, we're replacing b. So our new interval will be called. So let's write out the values that we got on this table. So I'm going to be rearranging this table because of lack of space. I'm going to be starting from 4 here and then continuing on. Okay, so we have our terms ready for our fourth iteration. So our c value is 1.25 plus 1.375 divided by 2. So our c value is 1.3125. Okay, and then our f of c would be equal to minus 0.8488384, which is not equal to 0, right? So we need to find f of a, f of b. So f of a, which is f of 1.25, is equal to is minus 0.8483. Okay, so c will be replacing a. So we have f of a here to be minus 1.7969. So that for the next iteration, we have our new interval. So this is equal to 1.3125, 1.375. Okay. You can still pause the video and try to solve for this fifth iteration. Okay. Okay. So I did the iteration and I got 0.0 to 1 decimal place. Okay. That's when to stop the iteration. But you can still go ahead. If I had done it to 3 decimal places, I'll be getting 0.03 something. But I choose to stop here because I think 7 iterations is enough to get very, very close to our value. Thanks for watching the video. If you learned how to solve the bisection method, you might as well share with your friends and subscribe to the channel. Thanks for watching again.